Hi guys, in this video we're going to work on the identity and inverse matrices on page 534. Alright, so what is the identity matrix? The n by n matrix IN with ones on the main diagonal. What is the main diagonal in here? Upper left to the lower right. And the zeros everywhere is, we call it as identity matrix of order n by n. So as you guys find out that this one is a n by n, which is a square. So your identity matrix is always 1, I2, 1, or I2, or I3, I4. That is giving you the number of rows and columns. So if you have I1, if you have I2, let's say that, and we're going to have 2 and 2, which is here, here, and here, here. You're going to have 4 numbers in it. What is my main diagonal? Here, here. Starting with my upper left to the lower right, and the other ones you're going to fill in just 0. That's what we call the identity matrix of 2 by 2. Okay? So once your I is written as A is written as Aij matrix, and then if you can say your A times I n, because we don't know what it is yet, equals I n A, that become just A itself, like multiplication. 2 times 1 equal 2, right? So that I is same as 1 this time. So at this time I n, we call it as a multiplicative identity. Same as a real number. Multiplicative identity of n by n matrix. And then you can look at the definition of inverse of a square matrix. So let's A is Aij, and then that is a n by n matrix. And then if there is a matrix B such that AB equal BA equal I, then I can say my B would be the inverse of matrix of A. Then it can be denoted as B equal A to the negative 1. So this negative 1, we don't really read negative 1, right? I just read negative 1 because that's the symbol, but we can just read it as A inverse. Okay? And then you can see that the 2 vocabularies all the way at the bottom of this page 534, we will see that not every square matrix has an inverse. We're going to talk about that after. If a square matrix has an inverse, then your A can be called as a non-singular matrix. If A has no inverse, then A would be singular. So I'm going to working on example 6 with you, and then we're going to talking about how we get inverse matrix. Alright, so example 6 on page 535. Prove that your A 3, negative 2, negative 1, 1, and then B 1, 2, 1, 3 are inverse matrix, which means that AB should be same as BA. It should be both as what? I. Then I can say my A would be the inverse of A, and then A is inverse of B. Alright, so first I have to check in my AB. Oh, we just learned that one, right? In the previous video. We have to see their order of matrix, which become, both of them are 2 by 2 and 2 by 2. Since those numbers are the same, my answer should be coming out what? 2 by 2 matrix. So A, B, how can I get this? You can use your first row with the first column, right? So I can do it. 3 times 1 is 3, negative 2 times 1 is negative 2. And first row, second column, 3 times 2, 6. And negative 2 times 3, which is minus 6. Negative 1 times 1, negative 1 plus 1 times 1 is 1. Now I'm using my second row. So that was my first column and second column. Now negative 2 times, negative 1 times 2, which is negative 2. 1 times 3 is 3. What do I got? What do I get? So I got 1, 0, 0, 1. Okay, that is what? Identity matrix, right? If I have a BA as same as another identity matrix, I can say A and B are inverse each other. So BA. Now my B is 1, 2, 1, 3, and then 3, negative 2, negative 1, and 1. Since both of them are 2 by 2 matrix, so your answer would be 2 by 2 matrix. So it is eligible to multiply that. Now what? You're going to use your first row and the first column. And you would have a 1 times 3, 3. 2 times negative 1, minus 2. 1 times negative 2, negative 2. 2 times 1 is 2. You always add it up. Now I'm going to work with my second row and first column. 1 times 3, which is 3. 3 times negative 1 is minus 3. 1 times negative 2 become negative 2. 3 times 1 is 3. So if you simplify, what did you get? 1, 0, 0, 1. Okay, so I can check it that both products of AB and BA become identity matrix. I can say A and B are inverse each other. Okay? All right, I'm going to give you time to work on exercise 33 on page 540. Once you're done, you can check your answer with me. Alright, so verify that the matrices are inverses of each other. What should we do? Samely, we can check it as A times B should be same as B times A. That should be both of what? I, 2. That's what we need to look for it because A and B, both of them has a 2 by 2 matrix. So the first one, AB, 2, 1, 3, 4. And I have a 0.8, negative 0.2, negative 0.6, 0.4. They are decimal. Still, you do the same way. So you need to use your first number of rows and then the first column. So 2 times negative 2 times 0.8 plus 1 times negative 0.6. That's your first. Now, 2 times negative 2.2 plus 1 times 0.4. Now my second, 3 times 0.8 plus 4 times negative 0.6. And then 3 times negative 0.2 plus 4 times 0.4. So you are, if you have 1001, then I can say, oh, partially they're going to, we can expect that they're going to have inverse each other. But they said verify, so it may or it may not. So let's check it out. 2 times 0.8 is 1.6, right? Minus 0.6. And I have my second, negative 0.4 plus 0.4. I have 2.4 minus 2.4, negative 0.6 plus 1.6. All right. And I may have 1 0, 0, 1. All right, there you go. So that is identity matrix. Now I can check it as a BA. BA. My B is 0.8, negative 0.2, negative 0.6, and 0.4. You should multiply with 2, 1, 3, and 4. Okay, let's repeat the same steps. Now, negative 0.8 times 2, 1.6. And then I have negative 0.2 times 4. That would be 3. So negative 0.2 times 3, which is minus 0.6. And then 0.8 times 1, 0.8. And then plus negative 0.2 times 4, which is negative 0.8. And then negative 0.6 times 2, which is a negative 1.2. And 0.4 times 3 is plus 1.2. And negative 0.6 times 1, negative 0.6. And plus 0.4 times 4, 1.6. Alright, so I can see that it will be 1, 0, 0, 1 as well. Since products A, B, and BA both, they're going to be identity matrix, I can say A and B are inverses each other. Okay, so let's go back to the page 535. Alright, this is a new. We need to find out inverse matrix for now. So how can we find the inverse matrix? So example 7 is showing that we don't use the find a specific inverse matrix. So I'm going to do example 7, and then on the next video we're going to working on how we can get the actual inverse matrix by calculation. So example 7 is this. Prove that the matrix A 6, 3, 2, 1 is singular. So we learned the word singular. What does that mean? A should not have inverse, right? A does not have inverse matrix. Then we can say A is singular. So we have to show it that A does not have inverse. So let's look at that. We just pretend that suppose that we have an inverse B, inverse of A, which is B. So let B is the inverse matrix of A. That can be written as X, Y, Z, W. Okay? Then if B is an inverse, it should be satisfied that it should be given to you in identity matrix, which is I2, because we have a 2 by 2 matrix given to us. Now I'm going to practice. I'm going to show you how we can get an AB. So my AB would be this: 6, 3, 2, 1, and my B would be X, Y, Z, W, and then it should be same as the value. Identity matrix 1, 0, 0, 1. Alright, so let me do the middle part. Middle parts, I have to multiply 6 and 3 with my first one. So 6 times X, 6X plus 3Z. Right? And then my next one is this: 6 times Y, 6Y plus 3W. That's what I got. And then keep going. My first one, here, 2 times X, 2X plus 1 times Z would be Z. And then I have 2 times y plus 1 times w. That would be this. Should be same as 1, 0, 0, 1. And do you guys remember what I mentioned at all the way beginning of this chapter? Matrix is deeply related about how to solve the system. Since these two matrices are exactly identical, I can rewrite this part as 6x plus 3z equal 1, right? And 6y plus 3w equal 0. 2x plus z equal 0. And 2y plus w equal 1. So I can rewrite in my matrix into the system. Okay, now I'm going to try to solve those to find out the specific x, y, zw. If I can find the value, then, my assumption, which is A has an inverse B, would be correct. So let's check on this. So I can do these two because they have a z and xz, and I'm going to work on those together. So if I solve my first system, 6x plus 3z equal 1, I can divide it by 3, all of it. Then I can get my answer, 2x plus z equal 1/3. Oh, that should be same as 2x plus z equal 0, or well, 1/3 cannot be same as 0, so it's not gonna be happen. And my second one, 6y plus 3w equals 0, and 2y plus w equal 1. I try to solve this system, so I divided it by, I times 3 on each side of my second one, so that I got 6y plus 3w equals 0. Just bring it down. And then I can just times with 3 times 2y plus 3 times w equal 3 times 1. That becomes 6y plus 3w equal 3. So let me just erase this. Okay, so I try to solve this, and then I, subtract that of each side. What I got 0 equal -3. Can they say? Not really. So I cannot solve the system, which means both of system does not have the solution. Okay, so my assumption should be wrong, which means that A does not have an inverse. So I can prove that my matrix A is singular, which means A does not have an inverse. Okay? Alright, I need you guys to work on number 37 by yourself. And then we're going to check this one out together. Okay, number 37. I have 1, 2, -1, 2, -1, 3, 3, 1, 2. Alright, so let's assume that this is my A. Let's assume that A has an inverse matrix, which is B. So A, B, C, D, E, F, G, H, I. I know it's gonna be a lot of work, guys. So just, be ready for it. Now, I can check my AB. If it's gonna be give you I3, then I can say A has an inverse for this. So let's check it out. So let me rewrite it. My A is 1, 2, -1, 1, 2, -1, 3, 3, 1, 2, multiply with A, B, C, D, E, F, G, H, I. That should be identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, it's a lot of work. So now, my AB, I'm going to pay attention in the middle part. So, my first is here. I'm going to working with my first, second, and third column. So my first one, it is A plus 2D plus negative G. That's one of my answer. The second, I got a 1 times B plus 2E plus negative H. And my last one, 1 times C, 2F, and negative I. That is my first one, okay? And my second one, I'm going to use my middle. And 2 times A, 2A minus D plus 3G. And 2B minus E plus 3H. Same as 2C minus F plus 3I. And my last one is here. Okay, let me just double check it. I don't want to make a mistake. 2B minus E, 3H, and then C, F, and I. Okay, so let me go into my next one. 3A plus D plus 2G. 3B plus E plus 2H. 2C. Nope. 3C plus F plus 2I. Plus F plus 2I. Okay, finally done. Alright, so it should be same as 1, 0, 0, which means I got I can say A plus 2D minus G should be same as 1, right? 2A minus D plus 3G should be equal to 0. 3A plus D plus 2G should be 0. So you have to work with first, second, and third with the 1, 0, 0, 0, 1, 0, 0, 0, 1. So let me starting with my first one here. So I'm talking about this. I'm just working on this one now, and I have to check my second and third. I told you that at the beginning it's a lot of work, right? So we are going to solve the system with the 3 variables now. So since my 2 of them, so when we work on this, I can label it as number 1, number 2, number 3. I can do 2 plus 3 so that I can cancel my D out. You guys remember how to solve your system, right? That's 0. 3A plus D plus 2Z equals 0. If you add them up, then I can cancel my D out. Then I would have 5A plus 5G equals 0. Okay, and then my second, I have to get rid of D again to leave as A and G only. So I'm going to do with 1 plus 2 this time. It's too big. Okay, like 1 plus 2. But if you do the 1 plus 2, you cannot cancel out. So what you need to do, you're going to do the 2 times 2. So that I got A plus 2D minus G equal 2. Oh, no, equal 1. And 4A minus 2D plus 6G equal 0. So if I add them up, that I got 5A plus 5G equal 1. Alright, oh, that's 5A, 5G, so 0 should be same as 1, but can 0 be same as 1? Not really, so I cannot find any value of ADG this time. And then now you should look at your second. So now I have to pay attention on here. Okay? So at this time, I'm going to use my space here. Okay. So B plus 2E minus H should be same as 0. 2B minus E plus 3H equal 1. 3B plus E plus 2H equal 0. Now, I'm going to label as 1, 2, 3, same as before. My first step for this, I'm going to add 2 and 3 to cancel the letter out. If you add 2 and 3, what's going to happen? 2B minus E plus 3H equal 1. 3B plus E plus 2H equals 0. If you add them up, you can cancel E out, which become 5B plus 5H equal 1. Now, I can Alright, now I can do, my goal is to get rid of E this time, so I can do 1 plus 2 times 2. Then I got B plus 2E minus H equals 0. 4B minus 2E plus 6H equal 2. If you're adding them up, that should be 5B plus 5H equal 2. Alright, so I had 5B plus 5H equal 1. If you are solving those two, I end up having 1 should be same as 2. But does it make sense? Not really. So, the last one, because guys, it's too long, it's getting too long. So when you do the exactly same way for your third one in here, your third one right here, if you do the same way, it does not find any value. So the conclusion would be you cannot find any value of A, B, C, D, E, F, G, H, I. So I could say my given matrix 1, 2, negative 1, 2, negative 1, 3, 3, 1, 2 has no inverse. Alright, so I hope this video helps you, and we're going to go over the questions together in, I think, in the live session, right? 3, 4, yes. So we're going to see tomorrow to go over all the questions. If you guys have any question, please let me know tomorrow. Bye.